The grip of a golf club is the only contact point for a golfer. It is important for the grip to coordinate with the head and shaft to maximize the player's potential. In the existing development of golf clubs, development of the grip has not been emphasized very much in spite of its importance. We at IOMIC have been focusing on how the twist of the golf grip torque in other words, influences golfing, and we've conducted research and development in this area. Let's measure a typical grip using the grip torque measure developed by IOMIC to measure the twist that occurs in a golf grip. To measure this, we prepared a grip fitted with a 15mm diameter stainless steel shaft. The side of the grip is fixed with a 40-kilogram weight, the average grip strength of an adult male at the time of impact. About 60 kilograms of load is given to the end of the stainless steel shaft using the weight device to artificially create grip torque, and the distance resulting from the movement of the shaft due to twisting is measured for comparison. First of all, we measure the grip torque of competing brand A. It is about 0.7 millimeters. Next, we measure the torque of IOMIC's sticky grip. It is about 0.2 millimeters. As you can see from the results of the experiment, the average grip torque of other companies' grips is about 0.4 to 0.7 millimeters, while IOMIC sticky is measured at about 0.2 to 0.3 millimeters. Supposing that the grip torque of these values occurred when the club face opened to the right at the time of impact, the expected average distance of push-out at 250 yards is limited to about 8.9 yards in the case of IOMIC sticky, while we can calculate it as about 14.9 yards for competing brands. These data are only measured for a fixed situation, and since side spin is added in the actual swing, we can assume the ball will fly further to the right. Therefore, we conducted an experiment in regards to the influence of grip torque in a situation close to the real environment, with the cooperation of Casco. We used a swing robot from Miyamae and an ultra-high-speed camera from Nabi Tech to measure the club face angle at the time of a center hit and an off-center hit with the same head and shaft, as well as data including the flying distance at that time. First of all, let's compare IOMIC's sticky to competing brand A. There is no significant difference between both companies' grips at the time of a center hit. Next is a comparison at the time of an off-center hit. As you can see, brand A's head is open further to the right due to a large grip torque. Next is a comparison with competing brand B at the time of an off-center hit. It is open to the right, similar to brand A. We used software to analyze the projected path of the golf ball to collect data on approaching balls. In the static data we collected for the grip torque measure, the push-out was calculated at about 8.9 yards. In the dynamic data, however, the push-out was found to be about 17.3 yards, since side spin, etc. was added as expected. In other words, the push-out for other companies' grips turns out to be about 30 yards in the dynamic data. Therefore, we found that IOMIC's grip portrays a more stable projected path compared with other companies' grips. We utilized data collected from these experiments to identify the key components of grip performance and to develop new grips. Through these studies, we at IOMIC hope to pursue a new relationship between the grip and head or shaft, as well as new technology that will contribute to the development of better golf clubs.